Well, can you believe it? We made it to our last new topic of the course. This one's titled Separable Differential Equations. So we've kind of hit the word differentiable equation before, but separable is new to us, and this is our last big topic. You'll see almost every exam has, a free response question dedicated to this. So a lot of people refer to differential equations actually as Calc 4. We have Calc 1, 2, and 3, and then the next course would be differential equations, and some schools call it actually Calc 4. So there's a whole course devoted to this topic, and probably the easy way that you'll hear most people refer to it is diff-EQs. Okay, a quicker way to say differential equations. But here's the deal. Let me outline the 4 steps, and then we'll run through 4 or 5 examples. So to find the particular solution of the given differential equation, these should be in your notes. First, separate the variables. Okay, you can only use multiplication and division. That's huge. So that each side of the equation contains only one variable. Step 2, find the antiderivative, which of course means integrate both sides. Step 3, find the value of c by substituting in the initial condition. And 4, solve the differential equation for the variable that appears in the numerator of the differential equation. And that's huge. That's how you know which one you're solving for. So let's try a few examples. All right, so here we go. Find the particular solution to y equals f of x to the differential equation with initial condition f of 1 equals -2 and dy dx equals y cubed times the quantity x minus 2 squared. So a couple things to notice. They're telling you y equals f of x. So basically they're telling you to solve for the letter y. Whoops. Another reason I know that is the y is on top in dy dx, which also means solve for the letter y. This initial condition implies that when x is 1, y is -2 on the function f of x, since they said f of. Alright, so we are ready to begin. Let me just re-jot this equation down. Dy dx equals y cubed times the quantity x minus 2. So the first note I want you to put in your book is that your first step should always be to cross multiply. And remember, our goal is to separate the variables. So we're going to cross multiply to do this. So you can easily put this over 1 if you don't have a fraction. And like I said, cross multiply. So dy dx equals y cubed times the quantity x minus 2 times dx now. So my goal is to get the variables separated. Y is on one side, x is on the other. The next little note I want you to make is the dy or dx, both I should say, always need to be in the numerator. And that's huge. You have not separated the variables unless dy dx are in the numerator. So you might be thinking you can move dy over by dividing it over, but then dy would be in the denominator, and that can't happen. You have to have them in the numerator. And lastly, let's just make one more note, which I know we stressed in the beginning, but let's say it again. You can only multiply or divide. There is no adding and subtracting. So the easiest thing to do here is simply just divide the y cubed over. And again, I'm going to rewrite this. Lots of rewriting today. X minus 2 dx. And quickly check. Have you officially separated the variables? Are y's only on one side, x is only on this side, and are your dy dx strictly in the numerator? And yes, they are, so we can move on. Our next step is to find the antiderivative, okay, which of course just means to integrate. So I'm going to slap an integral on both sides. Okay. Now, there is no rule, quotient rule I should say, for integrating. So the smartest thing to do, of course, is just going to be to rewrite this. If your y cube is on the bottom, simply bring it up by making a negative exponent. And now we'll just quickly integrate both sides. Remember, you're adding 1. Get y to the -2 divided by -2 equals x squared over 2 minus 2x plus c. And maybe you're asking yourself, why didn't I put a plus c on both sides? And that's a great question. Basically, all I'm saying is if I put a constant here and a constant here, and I put the constants on one side, I'm still going to get a constant. So it's, it's kind of more formal to just put the plus c on the one side with the x. Okay, and I just want to be clear, make sure you put it with the x. At this point, you have officially separated the variables and integrated. And now, if we have an initial condition, we would want to use that. But before I do that, I actually want to rewrite this term. I don't like negative exponents, so I'm going to really say this is 1 over negative 2y squared equals x squared over 2 minus 2x plus c. And I want you to box this in at this point. Okay? So now I'm going to use that initial condition, and if you recall it was f of 1 equals negative 2. So my x value is 1, my y value is negative 2, and I'm just going to simply solve for c. Okay, so negative 2 squared is 4. That leaves me with negative 1/8. And I'm going to leave this as 1/2 minus 2 plus c. And again, we've talked about this several times. Probably the easiest method to kill your fractions is just to multiply every term by the common denominator. So I'm just going to multiply every term. And again, just make sure you do it to every term by 8. So I'm left with negative 1 equals 4 minus 16 plus 8c. Remember, you balance an equation by doing it to every term. 11 equals 8c, so I get c equals 11/8. Now again, you're still, I just want to make a note, you are not done here. Okay, these equations are long. You are now going to take that value you have for c and substitute it, keep going here, back into the c in this equation that we boxed in. Alright, so we're going to rewrite that and plug 11/8 into the c value. So negative 1 over 2y squared equals x squared over 2 minus 2x plus 11/8. And now your goal, of course, remember, it was dy dx, so we have to solve for y. So I would say at this point, I'm just going to multiply every term by negative 2. Obviously, I'm using the 2 here to kill that and the negative here. So I'm just going to say multiply this side by negative 2. And again, you can write it next to every term, or you can just say, quantity times negative 2. So that leaves me with 1 over y squared. And remember, I'm multiplying every term by negative 2. So I've got negative x squared plus 4x minus 22 over 8. All right, still trying to get y by itself. So again, I'm going to multiply both sides by y squared. Kill that equal sign there. Multiply this by y squared, so that kills those. I've got 1 equals, and I'm not actually going to multiply this through. That wouldn't actually benefit me at this point because my goal is to solve for y. So I'm just going to say times y squared, and then to get y squared by itself, I'm going to divide both sides by that amount. So I'm going to get 1 over negative x squared plus 4x minus, I'm just going to reduce that fraction, 11/4 equals y squared. Okay. Now, I have to take the square root of both sides, and one of the most missed things, and I just didn't include it at the moment, is when you take a square root in math, you actually get a plus and minus. Okay, and that's huge. Make sure you catch that you get a plus and minus every time you take a square root. So I've got plus and minus the square root of 1 over negative x squared plus 4x minus 11/4 equals y. Now, our last little check is you can't actually leave the plus and minus in the equation. You don't get two answers. If I graph something with a plus and minus, it would look like this, and it wouldn't be a function. Okay, so I can't leave the plus and minus. There is something in the problem that gives it away, whether it is the plus or minus, and it's that initial condition. Recall that f of 1 equals negative 2. So when you plug 1 into this equation that you solve for, you have to get out a negative 2. So the only way to get out a negative 2 is if your final answer is a negative. Okay, so you don't ever have to guess. Oops, that should be over 4. This initial condition will tell you whether you want the positive or the negative. So my final answer, here it is. And we've solved our first differential equation. All right, we're ready for example 2. Find the particular solution to y equals f of x to the given differential equation with initial condition f of 3 equals 2, given that dy dx equals sine of pi x over 3y squared. Okay, so recall this initial condition. What I'm really saying is when the x value is 3, the y value is 2 on the function f of x. Also, the function they want me to solve for is y because it's dy over dx, and they tell me that there as well. All right, so first step's the same, always cross multiply. So I've got dy times my 3y squared equals the sine of pi x dx. And what a nice one to begin with here. On my first cross multiply, you'll notice that the variables are already separated. So I can jump to step 2, which is now to integrate both sides. So slap your integral around both sides. On the left-hand side, I've got just a nice integration. I'm going to add 1 and divide by 1, so I get y cubed over 3, which is just going to be y cubed. On the right side, I've got a little bit of work to do. If you were to take the derivative of the sine of pi x, that would be chain rule. So that means I need u sub. So my u is pi x, my du is pi dx, and when I solve for dx, I get du over pi. All right, so again, this is work off to the side, and this is how 99% of them are going to be. So I really have the integral of the sine of u times du over pi. Okay, now I'm going to rewrite this. You'll notice I already integrated the left side, so I'm done with that side. I'm going to pull out the 1 over pi. I'm keeping the integral because I have not integrated yet. All I did was u sub. I have not integrated. Keep going. So I've still got y cubed here equals my 1 over pi. Now I can integrate. Who do you take the derivative to get positive sine? Well, hopefully you're saying negative cosine. So there's my negative cosine. And I'm going to substitute my u back in, which was pi x. And don't forget you have a plus c. All right, we'll box that in. We've done all of our integration. Our calculus is done at this point. We're just going to go get that initial condition. Remember, f of 3 equals 2. So I'm going to plug 2 into the y value. Oops, 3 into the x value, plus c. And my goal is to solve for c. 2 cubed is 8, negative 1 over pi. All right, cosine of 3 pi. Don't get stuck on this, just picture your cosine graph. Okay, it goes 1, 0, negative 1, 0, 1. So that's 0, pi over 2, pi, 3 pi over 2, 2 pi. Now you get it to 3 pi. So 3 pi would be down here, which is going to be negative 1 plus c. So I've got 8 equals 1 over pi plus c. 8 minus 1 over pi equals c. All right, now that you've got c, remember you are not done. That goes back into your equation. So I've got y cubed equals negative 1 over pi, cosine of pi x. And now instead of saying plus c, I'm going to say plus 8 minus 1 over pi. And just one more step to go. I want to solve for y, so I want to take the cubed root of both sides. So I would say y equals the cubed root of negative 1 over pi cosine of pi x plus 8 minus 1 over pi. Now notice this time I'm not putting a plus minus. So kind of just some basic algebra review. You're only putting the plus minus when you take a square root, or I guess I should say an even root. Odd roots can't be both positive and negative, so it's just y equals the cubed root of this chunk. And there you have it. All right, now a lot of times they're not going to use x and y. So let's try this one. Given h equals 16 at time t equals 0, where h is the height in inches of water in a container and t is the time in minutes, solve the differential equation. H of t equals negative square root of h over 2, for h is a function of t. So again, how do I know what variable they want me to solve for? It's always this numerator here, this top variable. So basically, instead of writing x comma y, I should be writing t comma h. They want me to solve for h. That's like my y variable. So the initial condition here, it says when t is 0, my height is 16. It also says for h, which means I'm solving for h as a function of time. All right, well you should know step 1 by now, so you can pause me, cross multiply, set up your two integrals, and integrate, and we'll see if we have the same thing. So again, pause it, try it on your own. So I've got to move this negative radical h over. Now you don't have to move the negative with it. I'm just going to divide both sides by radical h. Okay, I'm not going to move the negative. Again, personal preference, you do whatever you want. So I'm going to say this side is 2 over radical h dh. Again, my dh is in the numerator, equals negative dt. All right, so now I can slap an integral on both sides. And I'm going to rewrite this side as I do that. I'm going to say this is 2, and this is really h if I bring that up to the negative 1/2 dh, equals the integral. Now, clearly, you're integrating something there. I'm going to say negative 1 dt. So some basic integrals. Hopefully, you've made it to the same spot, and you've integrated, and you're just checking with mine. Remember, I'm going to add 1 or 2 over 2, so I get h to the 1/2 times 2, so that's a 4, equals negative t plus c. Okay, make sure you don't use x and y now. We're using t and h. And at this point, I'm just going to box that in, and I'm going to go get my initial condition. And remember, that was when t equals 0, the height was 16. So if I keep going, I've got 4, 16 to the 1/2 equals 0 plus c. This is really the square root of 16, which is 4. So I've got 16 equals c. Okay, take that c value you found and substitute it back into this function. So I've got 4, I'm going to call that radical h equals negative t plus 16. Remember my function was dh dt, so that tells me I want to solve for the letter h. So at first I'm just going to divide both sides by 4. So I've got radical h equals, now again, it's one term on the bottom, make like a beaver and split if you're going to actually divide them. I'm going to say negative t over 4 plus 4. And then lastly, if I want to get rid of a radical, I'm going to do its inverse, which is to square both sides. So I've got h equals the quantity, negative t over 4 plus 4 squared. And there you have it. Another perfect separable differential equation. All right, well, we've made it to the last example for the night. Let v of t be the velocity in feet per second of an elevator at time t equals seconds. The velocity of the elevator satisfies this differential equation with initial condition given. Find an expression for v in terms of t. So again, they're telling you to solve for v. So solve for v using the letter t, and also this to v dt's on top, implying solve for v. So I just want to be clear. When the time is 1, those are my two letters, the velocity is 3 pi over 2. That's what this initial condition is telling me. All right, so again, I think you can take this one on your own, cross multiply, integrate both sides, and we'll compare before we find the plus c. So pause it, try it on your own. All right, so there's mine, and again, pause it and check if you need to. I'm going to integrate both sides. The left side is fairly simple. Its antiderivative is sine of v. Now this side, again, if I need to take the derivative and need chain rule, I need to use u sub, and I keep trying to tell you this is about 90% of them, and I'm just doing the easy ones today. So u sub on this bear. All right, so I get du over 3. Now I'm going to keep my integral because I haven't actually integrated. This is u to the 6 du over 3. Okay, still haven't integrated, so I keep the integral. I'm going to pull out my 1/3, and I'm integrating u to the 6 du. Okay, now when I integrate, I can take the integral symbol away. So I've got 1/3. If I integrate u to the 6, I get u to the 7 over 7 plus c. And I'm going to plug that initial back in. So 3 times 7 is 21. And I get, that was 3t minus 4 to the 7th plus c. All right, let's box that in. Let's go get our initial condition, which I believe was when t equals 1, my velocity was 3 pi over 2. So when time is 1, my velocity is 3 pi over 2. So I should have the sign of 3 pi over 2 equals 1 over 21. Plugging in 1, 3 minus 1 is, 3 minus 4 is negative 1 to the 7th plus c. The sine of 3 pi over 2, so picture your sine graph. That gets me a negative 1 equals negative 1 over 21 plus c. I'm going to add over my 1 over 21. Okay, so again, for quick math, I'm really calling this negative 21 over 21 plus 1 over 21 gets me negative 20 over 21 equals C. So again, still not done. Going to take that and plug that back into that equation. So I should get the sine of V equals the quantity 3t minus 4 over 21, that's to the 7th, and then I'm subtracting my C value, which is negative 20 over 21. Now remember, you're not done until you solve for V. So think back to your basic trig, algebra 2 trig. You can't divide sine over. The only way to kill a trig function is to take its inverse. So I'm going to do sine inverse of both sides. Okay, so simple sine inverse of both sides, that kills my sine function. So I get V equals, and again, you can either use arc sine or sine inverse of the quantity 3t minus 4 to the 7th over 21 minus 20 over 21. And there you have it. So you've got a taste of separable differential equations, also known as diffie-qs, and we'll step our game up tomorrow, but hopefully this is a nice, easy one for you. Have a great night.